Hi, everyone. Welcome to GraphQL Data APIs in Aura. This session is being presented by Liam Doodson. And Liam, I'll hand it over to you to get started.
Sounds good. Hey, I'm Liam. I'm a software engineer on the developer services team here at Neo4j. So my team focuses on building MCP servers for Neo4j, the Aura API and related tooling, as well as the GraphQL library and our hosted GraphQL Data API in Aura, which is what I'm going to be talking to you about today. I guess more specifically today, I'll give a bit of an overview of what GraphQL actually is, before talking a bit about our GraphQL library here in Neo4j. Then I'll do a quick demonstration of how you can experiment with the GraphQL library using something called the GraphQL toolbox. And then I'll show you how we can go from that experimentation into production by deploying a GraphQL Data API into Aura. But yeah, first of all, what is GraphQL? So essentially, it's a query language and runtime for APIs that was developed by Facebook and made open source in 2015. And so the way it works is essentially you define the shape of your data using what's known as GraphQL type definitions here. So here I've got a quick example. So I've got a type movie, and movies, I've said movies are always going to have a title, which will be a string. You can tell they're always going to be there because of the exclamation mark. And then I've said optionally, they can have the year that the movie was released as well. So then as a user of the API, I can ask for exactly the information I want from the API. So here I've said, fetch me a movie with the title The Matrix, and give me back the year it was released as well as the title. As you can see, I've then got back results in the shape that I was expecting based on that query. But say maybe I already know the title. I didn't want to get that again. I could have left that out, and it wouldn't have come back in my results. So GraphQL is really good, especially from the client perspective, because again, we're as a client, we know exactly what we're going to get, and we're not going to be overfetching any data. But there can be a few pain points, especially if you're the maintainer of the GraphQL server. So one of those pain points is you have to write quite a lot of boilerplate. So even for that very simple example I've given, you can see I've defined that type movie. I've also had to define how you can get it from the database. So I've said you can get a single movie by giving us the title, and if we find it, we'll return it to you. Or you can fetch all the movies from this API. And then, as with lots of APIs, you probably want some CRUD operations. So here I've defined some to create, update, and delete a movie. And then, as you might expect, you also need to define what's known as resolvers. So this is the actual code that executes when you query data from this API. So here I've defined a simple resolver for this movies query. So this is the query that's going to fetch all the movies from the API. So as you can see in this example, I'm just going to run some simple cypher, which fetches all the movies and returns them to the user. But writing these resolvers can get quite tricky quite quickly. So if we were to extend this API to add an actors type and say that movies can have these actors, we then probably need to, we need to define how we're actually going to fetch those actors. So we'd probably leave that movies query alone, right? Because if the actors aren't requested by the user, we don't want to fetch them from the database because we don't want to overfetch or do unnecessary operations. So instead, maybe we define a specific resolver for the actors property on movies. And so if a user requests the actors for a movie, we'll run some simple cipher which will match that movie using the title and then fetch the related actors. But you might see where this can start to go wrong quite quickly, because say we returned 100 movies from that initial query, we're then going to have to run this actors query 100 times. So for a single query that's come to our API, we've actually hit the database 101 times in that example, or n+1 times, ending the number of movies we returned in the first place. So yeah, as you can imagine, there's quite a lot of overhead from all those extra queries, and it's not the most performant way to do things. And especially at Neo4j here, with us being a graph database and this being a graph all the way from our storage layer right the way through to the API, yeah, we thought the experience could be a much better. And this is where the GraphQL library was born. So as with normal GraphQL, you need to define the shape of your data using GraphQL type definitions. But unlike before, I don't need to define any queries, mutations, and resolvers. Instead, the GraphQL library is going to automatically generate all of that for me. And then to solve that performance issue, instead of doing lots of little different Cypher queries, we'll translate a single GraphQL query into a single Cypher query, which is going to hit our database. And then we also provide extensive options for filtering and pagination. So that, again, we make sure you're not going to be fetching any more information back than you need. And then we also provide lots of options to customize the schema, or the API that we're actually generating with this library. And I'll share a couple of examples of those in a second. So at relationship, which is going to show how we represent relationships in our database, or at cypher to extend our API with powerful graph queries. So yeah, cool. With that, it's time for a quick demonstration. So I guess the first thing to note is I've got a Neo4j database running in Aura, and it's running what's known as the recommendations dataset, which is something we offer at Neo4j, and I'll share the link to that at the end of this. So yeah, I'm going to head over to something called the GraphQL toolbox. And to get started, I just need to enter the URL and the password for my database. So I'm just going to paste those in now. Cool, and then we're going to click connect. So the first time you enter the toolbox, you'll probably see something like this. So I'm going to click this introspect button, and what it's going to do is it's going to have a look at the data in my database, and it's going to automatically generate some type definitions for me based on what's in there. So it's a really quick way for you to get started and start trying this out. As you can see, I've got similar data to what we were talking about before. I've got actors and movies, but there's quite a lot more here as well. So for the purposes of this demonstration, I'm going to cut it down to some smaller type definitions, which I wrote earlier. So yeah, cool. So as before, we've got a type movie, and I said this maps to a node in the database. And as before, that movie has a title, and optionally the year that it was released, and it also has actors. And I said, these also map to a node in my database. And in order to get to actors from a movie, we hop over the acted in relationship. And I've also said that this relationship can have some properties, which I've defined here. So an actor has the role that they play in the movie. And then it's also worth noting this data set also has some genres. And so I've added an extra property using the cypher directive, which is going to fetch me some similar movies. And to do that, I've written a simple cypher statement. So I'm going to match this being the parent movie, and I'm going to look for movies with similar actors and genres, and yeah, return the three with the biggest overlap. So yeah, cool. I'm pretty happy with these type definitions, so I'm going to go ahead and build my schema and start seeing what I can do with it. So yeah, as you can see, I've actually played around with this a little bit already. So the last query I did, I was looking for the movie Toy Story, and I wanted the first 3 Toy Story movies. If we click play, that's worked, except I've probably gone for the wrong filter here. I don't want it to equal Toy Story. Instead, I want it to start with the words Toy Story. Oh, if I can type. And yeah, okay, cool. As you can see, that's working now. I've fetched the first 3 Toy Story movies and their title. So that's worked pretty nicely, but maybe I want to fetch some more information. So I'm interested in the year that they were released. As you can see, that information now gets added. And then maybe let's have a look at some more graphy operations. So let's have a look at my actors and the roles they played in these films. And in fact, just the roles that were played in this film. And let's get those actors' names as well. So yeah, cool. That's working pretty nicely. I can see Tom Hanks played Woody. So yeah, which I know to be true. So this seems to be working nicely. And then finally, let's try out that similar query and find the titles of some similar movies. And yeah, I can see Toy Story 2 and Toy Story 3 are similar to Toy Story 1. So as you would probably expect. So yeah, that looks like that's working really nicely for me. It's nice to see just how performant this can be going in a single query against the database to fetch quite a lot of nested information. So yeah, so I'm happy with these type definitions. So I guess my next stage is I want to deploy this into production so I can start to get some real value out of this API. So I'm going to come back over to the Aura console and head to the Data APIs tab and click Create API. I just need to give it a name and select my database and then enter the credentials for that database. Again, can't type today. Cool, and the password, paste that in, and then those type definitions from before. Cool, and there's one last thing I need to define, which is an authentication provider. So this is how I'm going to actually access this API. I've got a couple of options. If you have like a third-party IDP, if you give us your JW cache URL, we can use that to validate any tokens you send us. But for the purposes of this demonstration, I'm just going to use an API key. I'll give it a name curl because that's what I'm going to be using it for. And I'll click create. And cool, so that's going creating now. I've got my API key. I'm going to make sure to save that. I'd probably recommend you download them, but for the purpose of this, I've copied that, so hopefully we should be okay. Cool, and yeah, as you can see, that's creating. It's got the name I've given it, and it's got an ID, and then we've got the URL that it's going to be hosted at as well. So yeah, while that's created, as I said, I wanted to build a curl command, and luckily we've got some functionality to help build that. Oh, and yeah, as you can see, that's ready nice and quickly, which is good news. So yeah, let's go build that curl command. So I'll paste in my API key and a simple query. And as you can see, we've actually built out this curl command for you, adding the headers you need to authenticate this request and the body of the request as well, which contains the query. So I'll copy that and come over to my terminal and hit enter. And yeah, brilliant. So that's worked. So as you can see, I've gone to my API and I've got some data back. So yeah, I'm pretty happy. And now I can go play around with this or yeah, get real people using it in production, which is really good news. And you know, I don't have to worry about this now because I know Neo4j is going to keep it seamlessly up to date for me, make sure it's always available and always nice and secure. Cool. So that's kind of everything I had to demo for you today. But I guess I've just got time quickly to talk about how you can try it out yourself. So to start experimenting with the GraphQL library, as I was doing before, all you need is a Neo4j database. You can try out a free database at the Neo4j the Aura console. And this is the link that you need to try out the GraphQL toolbox, which is what I was using before. I'd also recommend you have a quick look at our documentation to see all the different ways that you can expand and customize on the API that we're going to create for you, as well as how you can actually use it as well from the client perspective. As I said, I use the recommendations data set, which you can find at that GitHub repo. I think it also has some GraphQL type definitions as well, which is really good news. And yeah, finally, the last thing you need to know to deploy a GraphQL data API of your own is you'll need a professional tier database or above. But the good news is you can start with a free pro trial today with no credit card info. So cool. That's everything I had time for. So yeah, I hope you have a good day. Thanks. Bye.